Few more questions, children. The next one. If the different permutations of all the letters of the word examination are listed as in a dictionary, how many words are there in this list before the first word starting with E? So, one word is given examination. In examination there are 11 letters. Examination. There are 11 letters in this word. Suppose we have to arrange the letters as in a dictionary. As in a dictionary means alphabetical order. First word starting with the letter A, then next letter, like that. So the question is, how many words are there in this list? When we arrange these letters as in a dictionary, how many words are there in this list before the first word starting with the letter E? So look this word. Here we have A. When we arrange in alphabetical order, the first letter A. Then we have one more A here. Then after A, then E. Then I is there, double I. Then M, double N. Then O, then T, X is the order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have these 11 letters. If we arrange as in a dictionary, first is A. So this A is fixed. Then we have to arrange these 10 letters. In how many ways we can arrange the 10 letters? Then after A, then we have double A is there. Then after that E. What is the question? How many words are there in this list before the first word starting with E? So before the first word starting with E means the number of words starting with A. That only we have to find, isn't it? Once again read the question. The examination word is given. There are 11 letters. We have to arrange these letters as in a dictionary. Then the question is, how many words are there in this list before the first word starting with the letter E? So the word starting with the letter E, before that means the words, number of words starting with the letter A. So required number of words means required number of words is equal to number of words starting with the letter A. The letter A. So how many words are there starting with the letter A? So the first letter is A, that is fixed, we can't change. We don't consider that A. That A is fixed. Okay. Therefore remaining how many letters? 10 letters. 10 letters. Letter can be arranged in how many ways we can arrange 10 letters? They can be arranged in 10 factorial ways. But is there any letter repeat? I. This A we don't consider. Why we don't consider A? The first letter is A. So this is fixed. Now we have to arrange only these 10 letters. In these 10 letters only one A. Okay. But I 2 times and N 2 times. That you have to write in the denominator 2 factorial and 2 factorial. Clear? So required number of words means number of words begin with the letter A. So that A in the first place. Then remaining we have 10 letters. That 10 letters we can arrange in 10 factorial ways. In that N 2 times and I 2 times. A is 2 times in the word, but the first letter is A. No change in that. So we don't consider that A. Okay. So here 2 and 2. Now calculate. 10 factorial 2 factorial into 3 into 4 into 5 into 6 into 7 into by into 2. 2 where we cancel. Okay, 4. Now you multiply. 3 into 4, 12. 12 5s are 60. 60 into 6 is 360. Okay. Then 28 into 9. Now 36 into 28. 6 8s are 48. 24, 28. Then 7. 1008. Then 1008 into 9. Correct? 8 7s are 8 9s are 72. 709. So 9072. Then 00 is there. So 9,07,200. That much words starting with the letter A. Next one. It is required to seat 5 men and 4 women in a row so that the women occupy the even places. How many such arrangements are possible? So total there are 5 men and 4 women means 9 are the total, and women occupy only in the even places. Okay, so first we can total 9 are there. So the first one I put a cross mark. This means it's an odd place, first place. Now the second, that's an even place. Third, fourth, fifth, sixth, 7th, 8th and 9th. So there are 4 women, they occupy in the even places. So this is second place, an even place. So one woman can sit there. Then 4th place, then 6th place and 8th place. So 4 women and 4 even places. So they can arrange in. So here 1 woman. So she can sit either in this place or this place or this place or this place. So for the first woman there are 4 different ways. For the second woman 3 different ways. One is already in this place. Okay. Then for the third woman 2 different place, and for the last one only 1 place. So 4 into 3 into 2 into 1, that is same as 4 factorial. So this 4 women can be seated in how many ways? Seated in 4 factorial ways. Okay, there is no other extra even place. 4 women and 4 even places. So 4 factorial ways they can sit. Now what about the men? 5 men are there and 5 odd places. They can sit either this place or this or this or this or this. So there are 5 places and 5 men are there. So we can write 5 men can be seated in 5 factorial ways. Therefore, required number of arrangements. Both we need, so we have to multiply. Required number of arrangements is equal to 4 factorial into 5 factorial. 4 factorial is 24. 24 into 5 factorial is 120. So 24 into 12. 2880. The next one. In an examination, a question paper consists of 12 questions divided into 2 parts, part 1 and part 2, containing 5 and 7 questions respectively. A student is required to attempt 8 questions in all, selecting at least 3 from each part. In how many ways can a student select the questions? In an examination, a question paper consists of 12 questions, which is divided into 2 parts, part 1 and part 2. In part 1 there are 5 questions, part 2 7 questions, and a student is required to attempt 8 questions, total 8 questions out of 12, in such a way that at least 3 from each part. At least 3 from each part means 3 or more. Okay, so there are 2 parts. So at least 3 from part 1 means 3 or 4 or 5 like that. So at the same time you have to take the part 2 also. Then only the total how many questions total the student has to attempt 8 questions. Okay. So we can take the different cases, isn't it? At least 3 from part 1. Part 1. That means from 5 questions the student has to select 3. Okay. So when 3 questions from part 1, how many from part 2? Total 8 questions. So 3 from part 1 means 5 from part 2. So this into 7C5. Is it correct? At least 3 from part 1. So 3 or more, that's the meaning. If we take 3 questions from part 1, 5 questions from part 2, then only 5 plus 3 becomes 8. Okay. Now either this case or at least 3 means 3 or more, that's the meaning. 3 or 4 or 5 like that, maximum 5 is here. Okay. So either this case or means you have to put plus symbol. What is the next case? 4 questions from part 1. So from 5 selecting 4 and the remaining 4 from the second part, that is from 7 4 questions. 4 plus 4 is 8. Or what is the other case? Or 5 from part 1. So from 5 selecting 5 into remaining how many questions? 3 questions. Remaining 3 questions from the next part. Okay. So 5 plus 3 is 8. Is any other case possible? At least 3 means 3 or more. At least 3 means 3 or more. It is 5 and 7. So 3, 4 or 5. Maximum 5 questions in this part. Then we can't write 6, isn't it? Since only 5 questions in the part 1. And at the same time, from the second part also at least 3. Okay. If we write more number here, then this will be 2. That is also not possible. So this is a possible cases. At least 3 from each part. So we consider at least 3 from part 1. So that is 3 or 4 or 5. Only these 3 cases possible. So in between plus sign. Now we calculate. So what is 5C3? 5 factorial, 3 factorial and 2 factorial. 7 factorial, 5 factorial into 2 factorial plus 5, 4 into 1 into 7 factorial, 4 factorial, 3 factorial plus 5C5 is 1, NCN is 1. 3 factorial, 4 factorial. So 5 factorial, 3 factorial, 2 factorial. We can cancel 3 factorial, then 4 into 5 by 2. 5 factorial cancel, 6 into 7 by 2 plus 5 into 4 cancel, 5, 6, 7 by 3 factorial is 6. Then 4 cancel, 5, 6, 7 by 6. So 5 into 4, 20. 20 by 2 is 10. 10 into here 3, 21. So 210 plus 5 into 7, 35. 35 into 5, 175 plus 35. So what we get? 175 and 35, 210 plus 210 is 420. The next one. From a class of 25 students, 10 are to be chosen for an excursion party. There are 3 students who decide that either all of them join or none of them will join. In how many ways can the excursion party be chosen? So in a class there are 25 students and 10 are selected for an excursion party. Okay, 10 students can attend an excursion party and there are 10 students that either they are in a group, 3 students, either they join, they decide that either they join the party or none of them will join the party. So in how many ways the excursion party be chosen? So 25 students in the class. Here there is a splitting. How we split this? 3 a group and the remaining 22 students. And we have to select 10 students. Okay. In that there are 2 cases. What is the case 1? Either these 3 students will join the party. The 3 students join the party. Okay. So these 3 join the party. Total we need 10. So already 3 joined the party. Then how many more we need? We need 7 more. That 7 from the 22 students. So selecting 7. Therefore remaining 7 students can be selected in how many ways? In 22C7 ways. Okay. There are total 25 students in which 3 students they decide that either all of them will join the party or none of them will join the party. So we take the first case as all the 3 students join the party. Okay, all the 3 students will join the party. Then we need only 10 for the party. So remaining 7 students we have to select from 22. That selection is 22C7 ways. Or which is this next case? Case 2. Case 2. What is the case 2? None of the 3 students will join the party. Okay. So we need 10 students. That 10 from again 22. Therefore 10 students can be selected from 22 in 22C10 ways. Okay. So what is the required number of ways? Required number of ways is equal to either the first case or the second case. So 22C7. This is the case when the 3 students join the party. So that 3 students is already in that 10. Okay, so remaining 7 from 22. That 3 is 3C3, that is 1. That's why we are not writing that. Okay, then plus what is the second case? None of the 3 students will join the party. So we have to select 10 students from 22, that is 22C10. And you can stop here since the calculation is difficult. 22C7 is 22 factorial by 7 factorial, then 14 factorial. So after cancellation, difficult to multiply. So in such cases you can stop. Okay. So I hope you understood this permutations and combinations. Thank you.